This is a Computer History Museum recording of a BBC World Service radio program made at the Computer History Museum. I would like to thank the Karsten Ellis Foundation, which helped to make possible the Computer History Museum's contribution to this edition of Revolutionaries.
Welcome, both of you.
Hi, Rory.
Hi, Rory.
Eric, can we start with a definition? I arrived in this country a couple of days ago, and the immigration officer, always a fearsome sight, at San Francisco Airport, asked me what I was doing. I said I was coming to do an artificial event. I said I was coming to do an artificial intelligence event here at the Computer Museum, and he stopped and looked at me and said, "What is artificial intelligence? How would you define it?" Which kind of caught me short, standing there waving my passport at the desk. So let's start with that. What would you have told that immigration officer?
So artificial intelligence is the study of mechanisms underlying thought and intelligent behavior, and the embodiment of these ideas in actual machines. It's about building machines that show various aspects of the intelligence of people. And let me say, it's not just about machines. AI includes understanding the computational foundations of our minds, of human thinking.
It's rebuilding the human brain?
It's pursuing scientific principles, engineering, machinery, and thinking about how we might harness these machines, these artifacts that we build.
Cynthia, you're developing a robot, Jibo, which you hope is going to be taking messages, reading bedtime stories, taking family photographs in people's homes from next year, I think. And it's combining and embodying existing AI innovations, isn't it? What do you see as the main ones that we're actually living with today, then?
Well, I think we are living in a very exciting time with respect to artificial intelligence because so many of these techniques are now being put into products that we are using every day as part of our lives. So, a favorite problem of artificial intelligence research was search, right? And now we have internet search. Everyone can go to Google, enter a query, and you can have, surf the world's information at your fingertips. AI researchers would love path planning. We'd love to plan paths, right? And now in a mapping app, you can enter a destination, it can plan that optimal path for you. We love to build vehicles that can navigate from point A to point B, and now we see autonomous driving cars. So many of these classic problems that the field has really been developing over time have now reached a point of maturity and performance where you're starting to see it as part of our everyday lives. And now you're starting to see things like virtual assistants, programs that have expertise, say, in medical diagnosis to help doctors make decisions. So it's proliferating at a very rapid rate.
So when I pull out my phone and talk to Siri in a kind of slightly annoyed way, or Cortana, he says quickly, because there's a man from Microsoft on stage, that is AI?
Sure. That's an embodiment of many techniques from AI to make that happen, to be able to understand what you say, to understand your intention, to be able to reason about what the request is, to come up with an action to deliver that request to you. It's perceiving, it's thinking. It can be learning your preferences, and then taking action to help you do something that you want to do.
And is it that learning that's the key? I took a robot into a radio studio the other week for bizarre reasons, and the rather grumpy, aged presenter, when the robot eventually was persuaded to talk to me, said, "It's only doing that because you've programmed it to do that." I almost said to him, "Well, you're only saying that because you've been programmed that to ask me that." But is that the difference? That these things are not just programmed, put in punch button A and B comes out, but to learn from the data that they're receiving?
I think, as Eric was saying, in order to build an intelligence, be it a human-like intelligence or some other kind of intelligence, it requires many, many, many different aspects, right? So our minds are not just learning, it's decision-making, it's planning, it's our ability to move our bodies, it's all of these things together. I think right now, there's tremendous excitement about the machine learning because we've started to develop techniques like deep learning that are able to start to perform on tasks like object recognition, speech recognition at a much higher performance than was possible previously. So there's a lot of excitement, particularly around machine learning now. But I would say in order to create an intelligence, it's all of these aspects coming together, like in your brain.
You can look at Siri and Cortana and Google now. as being effective because they're sitting on top of a symphony of successes in artificial intelligence. Speech recognition alone has marched along for decades, and it's gotten to a point now where people are a little frustrated when a sentence is not understood. When years ago they would have been mystified and astounded by
We've
a
lost
word
our
being
sense
understood.
of wonder, haven't we, in some of this?
Well, I think that the aspirations and goals will continue to stay ahead of where we are. But it's a symphony of techniques.
That's right.
I said at the beginning that we seem to be at a particularly exciting place in the history of AI, but it's been a long time coming. Back in 1965, the US psychologist Herb Simon said, machines will be capable within 20 years of doing any work a man can do. Well, it hasn't happened like that. Why has the promised advance in AI taken so long, and what's actually changed to accelerate that in the last few years?
Well, I think some of Herb's ideas and his aspirations are right on. Once in a while, we get the parameters a bit wrong in terms of the timing. One big revolution has been the shift to thinking about probability, moving from programs of the kind we see represented in the Computer History Museum here, many of which were logic-based. If A, then B. If B, then C. But in reality, intelligence is deep in the fabric of what it means to be intelligent in a complicated world, means making great guesses under great uncertainty. A doctor, for example, seeing a few symptoms and looking at a patient, needs to guess and reason and infer best actions to take, best assessments to make under great uncertainty. And this notion of probabilistic programming, probabilistic representations, came online, became a focal point, and it's not separate, of course, but making the links to logic and building rich representations that could actually explain how limited or bounded systems, agents, bounded people, can do well in complicated universes with probability.
And that probabilistic programming came along at the same time as this vast flood of data, this big data era, and sheer increase in computing power. Is it those three coming together?
Well, there's been an incredible, lucky confluence of going from very expensive media for storing little bits of data in the 80s. It's remarkable how today it's almost free to store data. We don't remember what it was like just a few years ago, how expensive that was. At the same time, the rise of the internet in our lives have meant that the tentacles of society, of social discourse, of economics, and all the data that goes along with that are streaming through servers and disk drives and memory tapes. This data, the computational power, as well as the storage, have enabled our algorithms to sing. We now have the ability to learn with machine learning algorithms, automatic procedures for learning from data, new kinds of predictive models that can predict everything from healthcare outcomes to the weather.
And I've been trying to get to grips with my tiny brain with this idea of probabilistic programming. That is saying that the old method is not enough, that 1 and 1 equals 2 is not enough. 1 and 1 might equal 3. Is that fair?
Well, it's more like this symptom and that symptom in a very complex state, or this failure in this complicated machine, an automobile, for example, doesn't necessarily, given a reasoning system, mean a simple single fault, but a panoply of possibilities. And systems with the ability to actually generate those probabilities and work with them and propagate them such that they know what they don't know and are still effective in the world. They also know what they need to learn, which is a very powerful and important thing.
Cynthia, when it comes to robots, which is your focus, they frankly don't appear to me to be as smart as what Eric has described. I mean, anyone who's watched, there's a wonderful video online of the Robot World Cup where robots are competing to play soccer, and they spend all of their time falling down. You know, we could say so do soccer players, but it's difficult.
Depends on the league.
It's difficult to be impressed with how far robots have come. What drew you to embodying AI in physical form? What made you think I want to make robots. That's where I want to go.
Yeah, so I would first say that, as a field embarked on artificial intelligence, we started off by thinking that things that were effortless for us must be easy for machines. So the fact that we can open up our eyes and we can see a scene, and we, as human beings, just understand it, turns out that's been an incredibly challenging problem, in that if you look at the evolution of our own brains, huge percentage of our brains have been evolved in order for us to be able to engage in vision. So the problems that are easy for us, well, they're easy for us for a reason. We've evolved over many, 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 many years, millions of years, in order to be excellent at those sorts of things. I would say things like social cognition, empathy, the ability to reason about your internal mental states. That's a gift that we have as human beings that we excel at. Very hard for a machine to do these things. So part of it is that. I would say for robotics as well, dealing with the real world, it is by definition unstructured. It's full of uncertainty. So as all the techniques that Eric has talked about definitely come into play in a big way in robotics. And again, when we think about our bodies, biological systems, in so many ways they are so vastly superior in their design than what we can actually engineer today. So we're coming off at a disadvantage. But in terms of why I'm excited about robots, really? Star Wars. Come on, Star Wars, right? I saw Star Wars when I was 10, and I just fell in love with those robots, right? So for many of us in the field, it does start there. It starts by the movies, by the books we've read.
It's all George Lucas's fault.
It's all his fault. It's all his fault. And I've always dreamed about this future of being able to have robots, artificial intelligence, as being part of our everyday lives, being able to help us. When I started doing this work at MIT as a graduate student, I started looking at this area that I ended up calling social robotics. And it was really about the question of how do you design machines that can actually work and collaborate in partnership with people. And the reason why is because at the time in Japan, they were building all these humanoid robots, these fascinating humanoid robots, and it was all about their concern about the global aging society issue that they were going to have, that they were going to have this proportion of elderly people and a lesser proportion of working age people, and how are they going to deal with that, right? And so they were looking at technologies. So the argument was humanoid form, because so much of our environment is engineered for this humanoid form, but they weren't thinking about the fact that people would be living with these systems. So the question that I came to was, how do we need to design these systems in order for anyone who's not an expert in robotics or AI can be able to interact with in a natural way and get value from these systems? So much in the same way that the computers went from big back room that experts used to the desktop, that was the moment in robotics, whereas robots were going to Mars and deep oceans and only experts used them.
From Mars to my front room.
To your living room. What does that have to look like when you talk again about people of all ages and stages?
Now, I'm told your PhD project was called Kismet and was a robot head that showed a range of different emotions. I'm told you had a long dark night of the soul, a difficult moment when you saw an exhibit which is now in the Computer History Museum, a child's toy called Furby, which seemed to be doing all that stuff already. Tell us about that.
No, so it was the article in Wired. I don't know how many of you remember this article. This was the article that came out before Furby was officially launched. And so I was building this robot, Kismet. Kismet was really, it was a mind shift in thinking about robots, not just as a technology that does physical work, to thinking about what does it mean to create a machine that has social intelligence, that has emotional intelligence. So I'm reading this article from Wired about this new toy that's about to come out called Furby. And the article is saying, it learns language, it has emotions, it understands you. I'm thinking, my God, my PhD topic is in a $30 toy, right? Good God. So I went online and I pre-ordered 2 of them because they were supposed to interact. I'm like, I got to see this for myself, right? So I'm like, I'm doing my work, I'm writing the code, I'm doing everything I'm supposed to do. I get the Furbies, they're in their boxes, I unpack them, I turn them on, I'm like, I'm okay. Yes. But the most successful toy for Christmas that year, so huge accomplishment.
So
yes.
Furby did certain things in order, and it wasn't reacting to its environment. And your work is actually about something different. It is about getting them to do what we do, which is learn from our environment and then treat us differently.
Exactly, to learn with people, to learn from people, to be able to collaborate with people. When we think about what it takes to work as a team, we take all of these mental inferences of the other person's states of mind for granted, right? What might you believe to be true based on what you can see? Maybe I see something different, so I know your beliefs might be incorrect at that moment. If that's the case, then I know you're going to fail at your task because you have the wrong beliefs. I can alert you to that, right? So robots that can start to reason about people in terms of your internal states that dictate behavior, and to allow the mental state, so to speak, of the robot to coordinate with your mental states, right? So it's a fascinating area.
Now, Eric, your early inspirations were slightly different. I mean, you began your academic career in medicine. You got an MD, is that right?
So for me, as an undergraduate in college, I was very excited about math and physics. I could get my mind wrapped around math and physics. I wanted to understand the universe deeply. Moved to biology, and I was mystified by biology, but I understood more or less how physics could explain a biological world, physics and chemistry. But then I hit mind, thinking, and I've remained mystified ever since. And so I headed off to get an MD PhD in neurobiology. My sense was that was the path. As a fresh graduate going into
We've all been there.
school,
Yeah.
we've all been there. And I came to Stanford University and was really excited about sticking electrodes into single neurons and being somewhere amidst thought. I know I'm there, I'm in, somewhere in a rat's mind. But I remember at the time looking up at this Apple II computer with an open case sitting in the lab, thinking to myself, what I'm doing is putting a little copper wire on the motherboard and trying to figure out what the software, what the intention of the programmer was, what's going on inside. This is not going to get anywhere quickly. At the same time, I began taking a whole bunch of courses in psychology and computer science, and the promise of the computational perspective on mind leapt out at me. And it's a very exciting and challenging area. It's, for me, the correct direction to go to understand mind. At the time, I already was in medical school and got excited about some of the hard challenges as challenge domains for AI, including how do you make time-critical, high-stakes decisions, for example, when a patient is gasping for breath during trauma surgery, with a reasoning system that has to make decisions under uncertainty and time constraints. And this led to the foundations or notions of what's bounded rationality from the point of view of uncertainty.
Are you basically saying that we're going to make progress in this field when we better understand the human brain, and actually progress in that area has been pretty slow itself?
Absolutely. We know very little about the mysteries of mind, the processes, procedures, architectures that let us all be together now and be experiencing humans. We know almost nothing at that level of what's going on. I believe that artificial intelligence, or the study of computational principles of intelligence, will both empower us in building machines that are intelligent, but also, and not only as a side effect, but as a goal, understanding human minds, vertebrate nervous systems.
Cynthia, you've been concerned with emotions, how robots and humans can work together sympathetically. What role does emotion have in all this, in cognition?
Yeah, so I can tell you that within the field of AI, the first papers on why researchers in AI should be concerned about emotion is because without them, we're not intelligent. It turns out that emotions and cognition are very deeply interconnected. So in some sense, whereas the cognition is the interpretation, it's the what's going on, the emotions are the so what, right? Why does this matter to me? Is this good for me? Is this bad for me? Should I pursue this or not, right? So emotions and affect, not necessarily like the strong swings of emotion, but just affective senses of judgments and appraisals are deeply intertwined with the way we think, the way we perceive the world, the way we learn, the way we interact with one another. So for me, wanting to understand how to build machines that can be simpatico with people. Understanding those dimensions were also really critical because we, as human beings, are profoundly social, profoundly emotional beings.
Now, you have both built machines recently that kind of embody your different fields of research. So, Eric, you've got an assistant. She's called Monica. She's friendly. She greets visitors. She tells them if you're busy, and she knows enough to work out whether to interrupt a meeting. She's actually an avatar on a screen outside your office. Cynthia, you're building Jibo, who's a kind of, it's been described as an Anglepoise lamp with a screen for a face, which is going to live in people's homes.
It's much cooler than that.
Yeah, it's much cooler than that. How would you say they embody your different approaches? What are you trying to do with that thing that's going to live in your home?
Yeah, so I would say my personal philosophy towards robotics and AI is that the thing that is so intriguing about them for us is the fact that they're not human. They're robots. They're different from us. And because of that, they can complement our human abilities. So whereas there's been a lot of predecessor work assuming that the goal is to create an identical human plug-compatible thing, that's never been my ambition. We have plenty of people. I'm more concerned with human flourishing, right? Whereas I can see how these technologies can help partner with us to help us flourish. So Jibo is anthropomorphic to help us understand these implicit cues that our brains are so wired to understand.
Why would I want a Jibo in my life?
It's, so we say it's the family robot, it's the family helper. So when you think about something that has a warmer experience, not a cold screen, but feels like a friendly presence, sort of like a companion animal, but a much more capable companion animal, something that can be connected to the internet, to skills, to services, and Jibo's a platform, which means that other people can leverage Jibo's AI, its ability to recognize you, learn about you, fit into your life, and through developer networks, increase its capability over time. So much like your smartphone with all of its apps, Jibo over time will have many, many skills so we can help you with many, many aspects of your life. Help your children learn, help your parents age in place, help you stay healthier, help you come up with recipes. I mean, you can just imagine the possibilities.
Eric, I slightly annoyed you earlier by describing Monica as a bit annoying. Tell us why Monica is not annoying and is doing a good job. And would Monica and Jibo get on?
Well, it's interesting, Rory, we were reviewing this session, and he just mentioned that your annoying assistant. And I said, I beg your pardon. I find her very pleasant and helpful. And I was serious about that. I have quite an affinity for Monica. We call my assistant, we named her after the person we scanned in who left Microsoft. We have her avatar with us right now. We've had others as well. We had Laura who left. We had her for a while. And we've had Todd. It's not all women, of course. It's we're gender neutral. I think in general, both Cynthia and I share the passion for the platform. What's the science that would support different kinds of applications? Jibo is learning about and hopefully will be competent in the common sense of the home. Monica is really interested, is focused on the common sense and the expertise you would need if you were managing a calendar, working with people in an office setting. We are not doing this necessarily to build an automated assistant as such. We're studying foundations. How can we have a system that can sit out in an environment, 8-hour days and beyond, and handle streaming perceptual information, sound, imagery from its cameras, acoustical information, who's talking when, how can it learn over time? Monica has 12 years of data about my comings and goings, and it leverages that very effectively in some of its applications.
Does Monica know better than a real human being whether to interrupt your meetings or not?
Well,
do you get annoyed when does Monica get it wrong and you shout at her?
I don't do that because I'm very, very emotionally cool with. But let me just make the comment that I have a new admin wonderful Jill. I haven't seen it fit to say Monica replaces Jill. They work together very beautifully. In fact, Jill is very happy to offload some tasks to people coming to my office, and I'm sure Jill, who sits 2 offices down from Monica, hears Monica chatting away to people, and she goes, "Okay, let Monica handle that."
Wait a minute. Jill's a real person, or
Jill's a real person?
Right. Okay.
So let me just say that. But Jill is new, and Monica has the first person name is kind of funny. We call Monica the assistant, actually, with a capital A. But the assistant has 12 years of data on meetings and my attendance, for example. And here's the kind of thing that Monica, the assistant, knows better than Jill, the human admin. When someone comes to my office and looking to schedule an appointment, the system might say, "Oh, God, today's completely booked," but then whisper and say, "I don't think Eric's going to that meeting at 2 o'clock today. You might want to stop by." And that kind of knowledge comes by collecting and examining thousands of appointments over a decade. And I can't say that Jill knows as much about that yet.
Who here amongst our brilliant American audience from Mountain View, Palo Alto, or further afield, who's got a question on anything we've covered so far? Put your hands up, please. We've got one there. And first, so we'll be coming to you at the back in a moment. But first of all, we've got this gentleman in the front row in the black T-shirt. So if you say who you are, where you're from, and what your question is.
My name's Mark Madonis. I'm from San Jose, California. I wanted to ask about, you mentioned having emotions with the artificial intelligence. I was curious, should that also include having the artificial intelligence be able to lie, get angry, and so on?
Eric, would you like to take that?
One of our systems, and we're doing a study right now, gives direction. We have a robot giving directions out at Microsoft Research. When you come out of the elevator, you can ask it for directions. And we're doing a study where the system is automatically figuring out if you're sincere or just testing the robot out because it's novel. And the robot will use this classifier, and once in a while will say, do you really need help, or are you just playing with me here? And people will say, I'm sorry, I was just testing you out. And the robot will say, fair enough. Now, where do you want directions to? And we're just watching the reaction between people and robot when it comes to notions of fairness. One other example I have to give you is somebody was wrestling with a room number, and the robot was to say, well, I don't recognize that room is not in this building. And finally, the person went to their smartphone and said, oh, no, it's 3102. The robot said, generates plans dynamically with it gives gestures down the hall, make a left, and so on. The person runs off, this young lady, and then she comes running back, because we have videos of this, and she says, thanks, and runs off again. This is someone rushing to get somewhere.
Next question. Someone's got the microphone there, and who's going to be next so I can get you all lined up? This lady here. Can we get a microphone to this lady here? Right, so first of all, this person at the back with a microphone.
Yes, my name is Casilda from Sunnyvale, California. And my question is for either of you. What would be more technically sophisticated? An AI robot that autonomously handles uncertainty, or an IA robot, an intelligent augmentation robot, that collaborates with people?
Cynthia, that's one for you.
Well, I think, the devil's going to be in the details in terms of what you mean by sophisticated. I'm personally far more interested, obviously, in the collaborative case, because I think that the nature of the coordination with a human being adds layers of sophistication and complexity that go beyond a robot that needs to perform, say, an equivalent task completely independently. It's having to do that plus coordinate that with a human in a seamless way. So I would vote for the IA.
Let me make one comment on this. I believe that I don't separate these things out. So I believe one of the grand challenges of AI is human augmentation. Mm-hmm. And it's a very, very challenging reasoning problem to figure out how, in different settings, I can assist this person to be better, to achieve their goals, to augment them. augmenting human cognition is a grand challenge for artificial intelligence.
And we've got a question over. Who's got the microphone? Who's got the microphone? This gentleman here, and then the microphone is going to go after that to the gentleman over there.
Peter Hirsch. I'm retired from IBM and Electric Power Research Institute, EPRI. I've been working in artificial intelligence for a number of years, and I think one of the things we have to understand is that what was artificial intelligence 50 years ago or 100 years ago is now just ordinary things like Cortana or Siri are part of our computers, everyday computers. Solving chess problems or checkers problems or solving differential equations are now ordinary things that we don't, are part here in the museum. So what you're looking at is the next generation of, and in a few years, that'll be ordinary as well, I presume.
Yeah, Eric, it's a good question. When will we have got there? I mean, there is this term full artificial intelligence. What does that mean?
You know, with all of our successes to date, we've largely been building, with a few exceptions, per the whole experimental paradigm, narrow wedges of competency. You know, a great recognizer for imagery, a speech recognition system, a planner, a chess player, a system that can help understand how proteins fold. When we think about an artificial intelligence, lay people and experts alike reflect about the prospects of building more general intelligences of the kind we see in people we collaborate with and live with that do incredible jobs and with many different tasks, react out of the box to situations in creative ways. I think we're now pushing on the frontiers of how to do this well. And some of this work will build on integrative AI solutions and methodologies of the form we saw with, for example, experiments that many of you know called Shaky the Robot, for example, and Monica, and other kinds of pursuits. I'd like to see more of that, and I think that will lead us to getting there in ways that will really impress our grandchildren, but of course become part of the background over time.
And
Dr. Horvitz, my name is Mark Zeller. My wife and I live in the San Francisco Bay Area. You mentioned you were interested in mind. My question is, in your studies, do you have any interface with the philosophers, particularly the German idealist philosophers like Hegel or Kant, the philosophy of mind, the critique of pure reason, human understanding, etc.?
Well, I mean, you asked me, I'll also respond, maybe Cynthia has some comments there too. Yes, and in fact, you know, during my Stanford graduate school days, I sat in plenty of interesting seminars. John Perry, Professor Brightrose, many fabulous philosophers, and we read Kant and Hegel and others. Kant had beautiful things to say about the assumptions we make, for example, about the minds and memories that people have, how we're all immersed with shared memory. And we actually cite that kind of work when we build our agents and give them short and long-term memory. We say, what did Kant say about that? And many of the things we do have links back to some of the core questions about what it means to be an intelligent agent.
Yeah, from my own work, a lot of it was actually inspired and motivated by developmental psychology. So how is it that we're born into the world as an immature entity, and through how we interact with our caregivers, with adults, we get into interactions and become that. So much more about the developmental aspect.
So Piaget, Ed Piaget, not a philosopher,
Piaget,
but a developmental psychologist.
Yeah.
who am I going to say? I'm going to zero in on this gentleman with the red braces. Can we get a microphone to him? This is going to be the last. It's going to be the last and probably the best question in this section. So no pressure, sir.
Thank you. Sometimes it pays to wear red braces. Nathan Brookwood, Insight 64, Saratoga, California. we're talking a lot about artificial intelligence in its ability to mimic human behavior. How important is it that the machines actually replicate the same sorts of thought processes that humans use in order to deliver that behavior, as opposed to just going through and delivering that behavior artificially? For example, some of the early chess programs didn't play chess at all the way a chess player would play, but could still beat a real chess player. So, the inside versus the outside.
Cynthia.
Yeah, so I think, for any competence that you could point to in humans or animals, you can implement it in a number of ways. There's often a number of different theories. Some might be purely computational, mathematical. Some may be highly inspired by theories of how we believe our minds do that. Now, you can get down to levels of abstraction or detail, down to the neural models, potentially, if you could. For me, it's really more about what is the cognitive fit of the behavior of the robot with the person so that they can really be an effective team together. Some cases, it does make sense to try to gain inspiration from, say, perspective-taking theory of mind simulation theory on how we perceive the mental states of others. We've implemented systems inspired by those ideas, right? But we're not modeling it down to the neural structures of the brain. But in doing so, we set up an intuition that we could fulfill in terms of how people think that the robot is reasoning that does lead to that seamlessness of the teamwork. So that's been my emphasis.
The Silicon Valley tycoon Elon Musk and the eminent cosmologist Stephen Hawking have both warned in recent months that the development of full artificial intelligence could spell the end of the human race. Should we be worried? Are we heading for the Terminator-like world that Arnold Schwarzenegger, the former governor of this state, so memorably enacted? Or is this all panic and hyperbole? I'd like to ask you, the people of Northern California, you're all gathered here, what you think. Is there anyone here who is worried? Now, let me pick somebody up. You, sir, you're looking a bit frightened. Do you have any scares about this world of AI and robotics?
No.
You're you don't lie awake and worry about anything. You're just a very calm guy.
Yes, I'm worried.
And why are you worried?
Someday, AI could, conquer the world.
Could conquer the world, right? There's a man who's worried that AI could conquer the world. You, madam, Kathleen O'Brien, it says here.
No, not really. I have concerns, but I think that they will not be. Any new technology, you have concerns about how it's going to be used, but I don't have any big worries.
Would you welcome one of those robots into your home that we've already heard Cynthia talking about? Would you want to share?
If they would do the dishes and clean the cat's litter box.
I'm not sure about that. Just put your hands up if you are worried. Oh, there's a lady here. Why are you worried, madam?
Asimov wrote his rules of robotics before I was born, and then wrote stories on how everything could go wrong. I'm not so worried about the robot that does my dishes. I'm worried about the government that gets this gigantic AI that looks into our lives. And not only do you have to worry about its intelligence, but its morality. And that's going to depend entirely on who programmed it in the first place.
You think it's another threat to our privacy?
Yeah.
What about you, sir?
Well, I'm afraid economy, because as soon as the robot takes 80% of the jobs, what will happen with those people?
That's a very good question, an area we're going to be covering in the next part of the program. And a lady here, are you worried?
Well, I'm concerned about how we incorporate ethical decisions into the robotics, because like any technology, they can be used to enhance human life or to harm it. So I think this needs to be addressed in the near future.
And we've got one more. We've got actually a forest of hands back here. Two worried people. Yes, sir.
Well, I'm worried about the fact that our government monitors us to a large extent. And to have a little device follow me around the house nagging me would be a terrible thing.
Okay. And you, sir?
I'm actually worried about a very similar thing. Just yesterday, I was surprised to find out that Google Maps knows everywhere I have been in the past few months, or maybe even the past year. I checked it down to every day or even every hour. So he knows where I live, where I work, which route I use to go to work, which drive-by drugstore I use to pick up my medicine, and all that already. If Google itself can do that, I wonder what the bigger governments can do.
Don't you feel confident enough to be able to control AI, to be able to, pull out the plug at the wall if necessary?
I just have to turn off my phone, not use it anymore.
Turn off your phone, always a good message. Thank you very much indeed. Well, we're now going to explore the long and short-term ethical implications of AI with our two distinguished guests. But we're not going to do that until I get back on the platform. So give me one moment. Cynthia, Breazeal, one of the interesting questions that came up there was how long is it going to be before our jobs are under threat? I mean, you're building these robots. Whose jobs are they going to be taking, and should we be worried?
So I think we've talked a lot about AI versus IA, and I think right now I'm very optimistic. I'm very excited, actually, that the dialogue, I feel, is actually starting to evolve from one of simple plug-compatible replacement to one of how can we design technologies that really do work in partnership with people to augment people. So I feel we have a decision that we can make in terms of how we design these systems. I think we are definitely in a time that's been discussed a lot in the media where these machines are going beyond the domain of brawn, things like manufacturing and picking up objects, into more areas of brain. And so it's not only sort of blue collar, but now increasingly white collar jobs.
If you're going to be doing a repetitive job, I don't know, a junior lawyer, a chartered accountants, I'm told, are under threat, you're going to be worried, aren't you?
Well, I think one question is really around the rate of change of innovation is happening very rapidly, and there's concern about can we update our business methods, our processes, our markets in order to adapt to that, right? I think what we're also seeing is an acceleration of the democratization of these technologies as well, and I don't think this point is raised as much in the media yet. So just as these technologies are being used, say, by corporations to try to get more efficiency within their businesses, these same technologies are increasingly being turned into platforms that empower many more people, not just within their corporation, but developers from corporations down to even individuals, to be able to create and design with these technologies and add additional value and services on top of that as well. So it's an empower and enabler of other people to create revenue and jobs, right? So it's a fascinating time, I think, because so many things are changing and are in flux. And I think the right questions to be asking are, how do we want to support our population? When we think about the future of the aging society, there's a whole other dimension there where, as we talked about, as a global society, the number of people going above retirement age is increasing, the number of people under retirement age is decreasing proportionately. How can we help people who want to continue to work and be productive do that through these technologies? How can we help the fewer number of people of working age be more productive? I think there's a much bigger, longer-term landscape that I think we need to consider as we think about how we can integrate these technologies into our society in a really beneficial way.
Eric, you and Cynthia are the sort of masters of this new technology. There's a whole population out there that sees it more as a threat than a promise, isn't there?
Yeah, so it's interesting to look at the current rise of concerns by some folks, including close colleagues of mine, and some scientists, most people outside of the computer science community, I think, are expressing some of these fears. Fears of intelligent machines and automation go back to Condorcet in the 17th century and 19th century work by Samuel Butler, and that work was cited by Alan Turing and then I.J. Good. I.J. Good, by the way, who talked about intelligence explosions and the last invention, was a consultant on the movie 2001: A Space Odyssey. I think that I want to be respectful of these views. I think it would be irresponsible to cast them aside and say they're crazy, but I think they can be.
But you'd like to.
No, I think they can and should be studied in a scholarly way. But they also, at the same time, and we will be doing that, at the same time, I believe looking at machinery we have right now to do verification of software, to understand how to guide and control and represent our intentions in software, I'm personally optimistic that we will keep these systems in human hands. We are the masters. Machines will be working with and for human beings. That's my belief, but we have to sort of work and be proactive about how these systems are fielded over time and stay with it. At the same time, I do not want to see these long-term fears distract us from shorter-term concerns which we need to be addressing even more urgently and acutely.
You've got this long-term study. You've got AI 100, a century-long study, the social impact of artificial intelligence at Stanford University. I look forward to reporting on the end of that study. So you take
actually, it's called the 100-year study of AI, but it's endowed to go forever.
Right.
As long as Stanford University exists.
Right.
We wanted to take it a century at a time.
So what you said, there are the longer-term questions, but what in the shorter term do you reckon is the biggest issue? Is it, will a driverless car know whether to run over a cat or not run over a cat?
I do think that there are some very interesting challenges with the rise of machine intelligence. And the way I look at this is think back to 1903 on that windy beach, Kitty Hawk, where there was this canvas-covered piece of iron and wood that took flight for just a short period of time. And just 65 summers later, there's a 747 taking off from JFK heading to Heathrow, and the people on board are just worried about did they get their salt-free meal successfully ordered for the flight, not thinking about all the nuances, the ecosystem control towers, scheduling flights. I think we're going to see this kind of rapidity of how machine intelligence rises into our lives in so many ways, and so many different categories and topics and issues will come to the fore. And these include privacy. How do these machines weave together copious data about people in a way that might protect them?
You made the point about from the Wright brothers to the jumbo jet over 65 years. That included 2 world wars. That is an area where people have fears about this technology. And I know a lot of scientists in this area are very determined not to see it used for military purposes.
Right, so
but that's going to be difficult to resist, isn't it?
The 100-year study calls out 18 topic areas in a framing memo, which you can read online, including machine intelligence and military applications, notions of how machine intelligence will influence very core notions of freedom and democracy when these systems can learn about people's beliefs and manipulate them in new kinds of ways in a democracy. What does that mean? How will they affect the way education occurs? What are some, not just the fears, but also challenges with fielding AI? Right now, as we speak, people are dying in cars and in hospitals in ways that we know machine intelligence could solve. So it's not that we need to worry about, at least in the short term and maybe long term, machine intelligence killing people. It's that not having today's existing machine intelligence is killing people right now.
Cynthia, a lot of the advances in robotics in your area are being funded by, for instance here, the Department of Defense. I mean, is that an issue for you? Do you ever sit back and wonder whether you're taking us down the right track because of the uses to which your robots could be put?
Yeah, is this working?
I think it's working, yeah.
So a lot of my funding actually comes from the National Science Foundation because a lot of my core interests are really about building robots that help everyday citizens. So education, I think, is a huge opportunity. A lot of the concerns about jobs really rest in how are we going to continue to train and retrain our workforce and educate our children so they can continue to grow and adapt with the changing technological landscape. And I think this is a huge opportunity for AI and for technologies. We're seeing innovations at the university level with startups like Udacity. Top institutions like MIT and Harvard are making their educational materials open for everyone. We're starting to see innovation K through 12 with Khan Academy. And with AI, you can imagine going from this lecture model, which is being replicated through these platforms now, to one of learning about the student, providing personalized attention. And we know from the literature that the learning gains of a person from personal tutoring far exceeds that of just kind of lecturing models. So the ability to bring that to people in homes, wherever they are, scalably, cost-effectively, is a tremendous opportunity for innovation that AI can help to address the concerns about. We're hearing about the job market right now.
On a broader level, a lot of what this is fundamentally about is whether a machine will ever have a consciousness, a sense of itself. The American philosopher Thomas Nagel wrote a famous paper called "What is it like to be a bat?" arguing that things other than humans could have consciousness. So can you both tell me, what would it be like to be a robot? Eric, have you got a view?
A very famous piece in machine vision is about what does the frog's eye tell the frog, and it's kind of putting us into the body and mind of a frog. I do think that we will come to master notions of what today we call consciousness, and I think it'll be it'll lead us to understand that it's nuanced and varied, and it's unclear what a thermostat or a control system in a plane or Monica by my door, when it gets more competent someday, the system, how much that will come close to notions of what you might call a situated, engaged, maybe even using the word aware system. I think this is still a mysterious question for us, and most AI researchers, while I would say, I'm going to conjecture here, are deeply interested in this question, but we often don't talk very much about it in our research.
Cynthia, do you talk about it? I mean, because you have this more kind of stroke, quotes, human relationship with your robots.
Yeah, so, I mean, I love to draw the analogy with the fact that we have relationships with non-human others as well, companion animals. You could argue maybe plants, other things that are intelligences or kinds of intelligences. There is the debate right now among philosophers and scientists whether dogs are conscious, right? So how do you measure that, right? I think the bottom line is there are people who are going to believe through the interaction you experience with them that they are. There are some who are going to debate that they aren't. I think in daily practice, it's going to get down to how we interact with them and how they respond with us. And I think we will engage and treat them kind of in terms of how we feel makes sense and is appropriate. So I think there's the philosophical debate that you can have ad infinitum, and you may never actually know. And I think there's what happens in practice in the world.
Do roboticists have these philosophical debates? Do they sit around wondering what would happen if?
Of course we do. Why wouldn't
you
we?
are philosophers.
Well, one view that comes up is if you build a system with the competencies of humans, in maybe a similar way, the similar constraints, would that system necessarily feel more or less like a person? This competency-centric notion of a conscious entity where consciousness is not really there. It's just the way systems who have these competencies happen to feel or be. That's their internal state. We have these kinds of debates, and we do reflect about these things quite often, but typically not in our scientific papers.
Cynthia, robots come in all sorts of forms. I mean, you could say that my dishwasher is a robot, but more and more we want them to have faces. We seem to want them to be like humans. I went into a factory the other day and saw a robot called Baxter, which was basically a robot. It had a kind of tablet screen, which you programmed it with, but the tablet screen had been given eyes and a nose and a mouth just to kind of make it look more friendly. Is that a fruitful path to go on? Should we be humanizing these robots?
So I think the important distinction between Baxter, which is the manufacturing robot you're talking about, as opposed to the traditional manufacturing robots that were designed to be roped off far from people and were dangerous and were never designed to actually collaborate in a shared workspace with a human being, the Baxter robot is designed to do exactly that. So the fact that you're working shoulder to shoulder with a human being, trying to design that interface, an intuitive interface between a person and a robot to be able to coordinate their actions, to understand what's this robot paying attention to, what's aware of, what am I aware of, in order to coordinate the joint action. That's why that's happening. You can even think about, intriguingly, autonomous driving cars. You know, when you're driving on human roadways, there's a lot of signaling we do, right? Especially in Boston. I know how many of you drive in Boston, right? I mean, there are times when you explicitly make eye contact, and there's times you explicitly don't make eye contact, right? And that's an important signal, right? So now let's say you have this robot car. How do you know what its intention is? How do you know what it's going to do? How do you predict its behavior? We read faces, we read body language in a very intuitive way.
So even if we have a driverless car, we're going to stick a tablet behind the wheel with
there may be some
emotions.
other cue, right? So the design space is actually quite rich. It doesn't have to be a literal face, but there probably needs to be some kind of signaling mechanism that is easily interpretable and understandable by people, where they don't have to be explicitly trained, because there are going to be people who've encountered these vehicles before and those who haven't, that people can understand. So, you know, there are analogies and metaphors that I think are intuitive to people that you can leverage. It doesn't have to be exactly a human face, but I think whenever you're designing a system that is designed to coordinate with people, the ability for people to be able to predict and anticipate behavior, as well as being able to do vice versa, is key. And these embodied cues play an important role in how we do that.
Eric, we've been getting slightly miserable in the second half of this program, and we've been worrying a lot, but let's zero in on the positives here. And in the short-term positives, where are we going to see AI improving our lives? In what areas over the next 5 years?
So I do think that we will see largely positive influences. That's my sense. Right now, there are about 1 million new papers being submitted every year in medicine, in biology, to PubMed, which is a resource for scientific papers. There's no way to keep up with that literature. Automated systems for understanding and integrating scientific knowledge into larger webs of understanding will be critical in powering up new directions in science. I believe we'll be seeing incredible scientific discoveries with these machines as scientific companions in the laboratory, helping not just to interpret and predict and model, but also helping to pose the right questions and to design scientific experimentation. So I think that these methods will have incredible upside in their ability to help humanity in the sciences across the board. I think that we see lots of applications in education, personalizing education. I believe, back to this augmented cognition area, systems can really learn about humans quite well, individually and in general, to understand what things they'll forget and need to remember, how to protect them for their attention from interruption, how to empower them to get things done. There'll be a lot of personal empowerment coming out of this technology. I see this technology is being used in ways that help people to translate quickly. Imagine being able to travel anywhere and in real time to speak to anybody else in the world speaking a different language. These kinds of technologies will change the landscape of how we communicate with one another across the planet. I think there are so many potential upsides that even the technologies we have now that I know today are buzzing in hospitals. We feel the technologies from our own team that are guiding treatments in hospitals by understanding which patients are at risk, for example, for a hospital-acquired infection before that infection sets in, which patients will bounce back within 30 days after discharge, and what do these special high-risk patients need in terms of investment for optimizing the economics of healthcare. And back to cars again. 1 million people are killed worldwide per current statistics, 30,000 deaths in the US from automobile accidents per year, 2,000 in the UK. How many deaths have happened during this conversation from people just trying to go from point A to point B? I believe that machine intelligence can literally wipe out that cause of death and injury. One last thing I'll end with, back to medicine again. There are almost 500,000 patients per the Institute of Medicine in the US dying every year based in avoidable errors in hospitals. we already have technologies that could take a bite out of that now, and I see that going further. So I see some of these short-term technologies being very powerful. In the longer term, really a general enhancement of human knowledge and scientific discovery.
Yeah, and I would just add, in a lot of these domains like education, elder care, healthcare, it's critical that these systems be designed to fit within our human care networks. I feel as a society we have a responsibility to each other, and when we talk about decisions in terms of when do you insert technology versus when should that technology enhance and support the human relationships is a really important design decision.
We've got to work with the robots and learn to love them. Right, we're going to our final question section. This is the BBC World Service. I'm Rory Cellan-Jones, and this is Revolutionaries coming from the Computer History Museum in Silicon Valley, California. We've been discussing artificial intelligence with Cynthia Breazeal and Eric Horvitz, two world leaders in the field. We've covered the power of algorithms, data mining, robotics, the future impact of AI. Who here amongst the citizens of Palo Alto, San Jose, Mountain View, all across Silicon Valley, this lovely, intelligent, sophisticated audience, who's got a question for our expert panel on anything we've discussed so far? The hands are shooting up all over the hall. You first, madam.
Hello, my name's Alicia. I'm a San Jose native. And my question is about, with multiple people developing AI and robots and different things, how do you forecast how that technology will kind of mesh together? So how will robot A talk to system B? You know, how do you picture that?
Cynthia, there's a vast amount of investment. Every big player in Silicon Valley is into this now. Are they working together, or is it a huge sort of arms race?
Yeah, so often you see a time where there's multiple standards and there's kind of a race to become the one kind of standard that everyone can communicate with. Once that happens, then you see a lot of acceleration and development. So for instance, right now in the connected home, there's many different protocols and interfaces. One of them eventually will settle out as being the dominant one, and then you're going to see a lot of people designing to support that.
Okay, next question coming up there, the lady there, and meanwhile, can we get a microphone to that gentleman back there? So, madam.
My name is Linda Dietz. I live in San Jose, California. And we've talked about ethics and morals, et cetera. So my question has to do with when things do go wrong, which they probably will in this imperfect probability world, who's going to have the jurisdiction over that, and how do you send robots to court, or what are we going to do about that problem?
Great question. We're going to have, that's a great short, punchy question. We're going to have a short, punchy answer from Eric.
Short, punchy answer is that we as a field are studying that topic of machine intelligence and law. And lots of interesting issues with liability, and tort law. I think that this is a very interesting area of study, and there are lawyers actually becoming specialists in this space.
Great. We've got a question there, and then we're going to have somebody over there. So if we get the microphone coming to there. But first, you, sir.
Hi, Steve Boyer from San Jose, California. And my question is, the artificial intelligence is so smart, maybe it can help me do my taxes. It knows where I work, what my earnings are, it knows where I'm invested. And if it can do my taxes, maybe it could do everybody's taxes. And since Congress can't come up with a way of amending tax reform, maybe the artificial intelligence could come up with a way of computing a proposed tax reform and do some social good.
You know, that's a great statement that may have been said to be slightly funny, but I do believe it frames an interesting direction, which is what's the role of machine intelligence in democracy and government, and how we optimize how things work.
Briefly, Cynthia?
No, I agree. I think it's a fascinating topic. It's a growing topic, and you know, again, as a decision-making kind of boost, I think there's a lot of opportunity there.
At least we want to augment the cognition of our leaders.
Yeah, augment the cognition of the people. Yeah.
And lady here, and then after that, there's going to be somebody right at the back over there.
Good evening. My name is Diane McGrath, and I live in Menlo Park. I wanted to address how AI is affecting the human experience. You know, my grandmother never wanted air conditioning because she wanted to sit out on her porch and talk to the neighbors going by. A lot of the people in this audience grew up without computers, and now my 6-year-old would rather interact with his iPad than with his parents on numerous occasions. I'm wondering, is a lot of this going in the wrong direction? Is it a bad thing?
Cynthia?
So, you know, I think the bottom line is it's all about balance. So I can definitely, I have 3 little boys of my own. I definitely see their fascination with screens and video games. And the bottom line is, you know, we limit screen time. You know, it's like understanding the right time, the right dosage, so to speak. I think it's critical. These are critical life skills or decisions that we make. For me, it's all about balance. Too much of a good thing is often not good. And so it's really about understanding how to strike that right balance.
Eric, are you firm about these issues?
Yeah, you know, I think one of the big topics we call out in the 100-year study is how will the rise of these systems change our self-conception, how we view each other. What will our grandkids or great-grandkids think when they see systems that kind of look like and behave like human beings in the environment, but are of our own hands? I think you've raised, and we should be raising these questions as a society in how we design and use these systems. And there's a very, very important set of questions and challenges in this space. I'll leave it at that.
We've got this gentleman here, and then we've got this gentleman here. So first of all, yes, you, sir.
Okay. Oh, hi. My name is Lok Nguyen. I'm an engineering intern from Southern California to the Bay Area. I have a question written down here. One of the many important characteristics of being a human is randomness and inconsistency, or sometimes we call it irrationality, when it comes down to dealing with similar circumstances. On the contrary, robots are known to be very good at recognizing patterns and keeping up with consistent implementation, or maybe it is by design to be efficient. In our popular working style or even lifestyle, we are overwhelmingly embracing efficiency. Am I wrong to say that we are both trying to mimic robotic features as being efficient and simultaneously trying to create robots by mimicking humans' behaviors? Would robots become a new species that are apart from human species, but far more superior in terms of efficiency, but hopefully getting along with us, complement humans' life instead of trying to diminish us? Maybe I'm too optimistic or pessimistic, depending on how you look at it. Thank you.
I think I can sum that up as, are we becoming more like robots as we try to make robots more like humans? Is that fair?
I don't think that's fair.
Right.
But
yeah.
So it sounds like you're suggesting that with the rise of smart robots in our midst, that they'll have a different set of characteristics than people. Is that what you were saying? And how will we work with these different kinds of teams, or with these collaborative experiences with these kinds of efficient systems? Is that your question?
Yeah, I think
time will tell.
Well, that's a cop-out.
Oh, no.
Lady here, can we get a microphone? Oh, no, we've got a gentleman here, and then we'll have the lady here.
I'm Mark Rabkin from Berkeley. The vision you've put forward eventually is to have these artificial intelligent networks and platforms ubiquitous. And what that means is that both governments and corporations, as well as criminal organizations, will have access to all of these. And well, right now, a lot of specialized skills and dollars are required to make these work. You know, you can see a time when these are much more available. So how do we balance all the positive things with these tools that will happen, with people using these tools for the negative things that will ultimately happen as well.
Yeah, let me just say that this is one of my big concerns, where potentially putting very powerful technologies in the hands of a few, or potentially in the hands of a few, and what do we need to think about proactively to minimize the influence of what we'll refer to as criminal AI? And that's a really important question, I think. We've been addressing that as a community as well. It takes kind of cybersecurity to the next level in some ways. In some ways, we're building systems that also now provide larger surfaces for attack, high-stakes systems, by malware and new kinds of malware. I think I don't want to sit up here and be Panglossian or only optimistic. I do think that we need to be concerned and watch some of the potential rough edges and costly directions, and one of which is criminal AI.
And are you Panglossian, Cynthia?
I am an optimist by nature, but I'm with Eric. I mean, you have to understand that there are two sides, of any technology, and you have to go into this with eyes wide open and be cognizant of these things. It's absolutely a discussion that needs to be had. It needs to be investigated. It needs to be understood.
I think we've got time for two more questions. This lady.
Khan, Palo Alto. Yes, I've heard that the social robots have been very successful with children with autism, also people with dementia and maybe beginning Alzheimer's. And I think it's interesting that a child who's autistic and is not interested in people would be interested in this robot, in this. So if you could comment on that.
Yeah, so yes, you're right. There's been a number of projects, research studies that have been showing the promise of social robots, especially for these populations. I think in the case of children with ASD, a lot of researchers are looking at how the social robot can be used as a therapeutic intervention in conjunction with a clinician, finding that because the social robot doesn't have the complexity of a human face, but can interact socially, it doesn't overwhelm the child. So you start to see social behaviors and competencies that you may not see if they're interacting with another person. And it's almost as if these social robots kind of prime the social pump, so then when the clinician comes in, they can actually have a much more productive session with the child. So it's a new area, but it's intriguing and it's showing a lot of promise.
And there are some ethical questions there too, aren't there? I was shown a robot recently which is going to be used in Japan to look after people with Alzheimer's, and the proposal was that this robot would have extraordinary patience, therefore would not mind hearing the same thing said 100 times in a row. Are we going to be comfortable with replacing human beings, irascible, imperfect human beings, with quotes perfect robots?
Yeah, so I don't think so, right? I believe that we, as part of the human life cycle, have to be involved with each other's life cycle. So again, I think this is a design decision. It's a best practices decision. The work that I'm more familiar with are these almost like pet robots that help calm people with Alzheimer's or dementia. So again, the care staff can come in and be more effective with them.
But Rory, on your topic, I'll just point out that some of the way we feel in terms of the fears, anxieties, and expectations and aspirations are cultural and come in waves and a part of fashion. Rory mentioned Japan. You don't see some of the same questions about robots taking over in Japan right now. You see a lot of focus of attention culturally on elder care, excitement about elder care. And so we have to realize that we're sort of immersed in a culture, sets of movies, sets of discussions. I don't mean to diminish potential concerns about where some things are heading, but we have to also realize that there are trends in how we think, sometimes very deeply emotional for us, and we don't realize that we're part of a wave that might pass or change in some way that's quite part of our culture.
And the last question, which is going to be a fantastic one, from this gentleman here.
Well, I hope so. My name is Greg Smith, and I'm from Saratoga. I was wondering what your thoughts were about opening up AI to the open source community and allowing multiple developers working all over the world on a project?
Absolutely, absolutely. I should say that I'm very excited about a couple of open source AI platform toolkits being developed in my lab, Microsoft Research, right now, working very, very closely with academic partners and others to field the platform for situated intelligence. One of them, for example, announced that publicly. So we love the idea of having this, of leveraging the imagination and creativity of the masses.
Yeah, I'd say that's definitely a trend that's ongoing. So whether they're platforms for commercial products or university projects, I'm seeing a lot of that happening right now. So again, the appreciation of the democratization of these technologies for all.
Yeah, one of the challenges is that it's so hard to build some of the base infrastructure, vision, speech, natural language. And if we can sort of provide creative folks with tools that get you up to a certain height and can really party at that level, it really will sort of light things up, I think.
Yeah.
Well, I've enjoyed enormously being with you here. It's been a fascinating discussion. You've been a great audience. Thank you for all your questions, all of them extremely interesting and thought-provoking. And on behalf of the BBC World Service, our partners and hosts, the Computer History Museum, and my producer, Charlie Taylor, please would you join me now in thanking our brilliant panel, Cynthia Breazeal and Eric Horvitz. Goodbye.